Hi, my name is Gail and I am about to discuss about the topic semiconductor. Well, first, what is a semiconductor? The capacity to conduct electricity defines a semiconductor material, and its conductivity properties fall between conductor and insulator. Semiconductors can serve as either a pure conductor or pure insulator under certain conditions. Furthermore, semiconductors, after forming a p-n junction, can alter the direction of electrical charge flow, which conductors cannot, as they allow current to flow in both directions. Examples of semiconductor materials are silicon, germanium, gallium arsenide, etc., where silicon is the most commonly used. Gallium arsenide stands as the second best semiconductor material and is used in solar cells, laser diodes, microwave frequency integrated circuits, etc. Types of semiconductors. Engineers have divided semiconductors into two main types, namely intrinsic semiconductors and extrinsic semiconductor. Semiconductors in their pure form are called intrinsic semiconductors and are barely useful as they are neither good conductors nor good insulators. In the pure form, the valence shell of semiconductor material carries an equal number of holes and electrons. Silicon has 4 valence electrons. These semiconductors are further divided into two types, named N-type semiconductors and P-type semiconductors. When a pentavalent material is used as a doping agent, 4 of its electrons in the valence shell create covalent bonds with the neighboring silicon atoms, while the 5th electron of the pentavalent element becomes a free electron. Such extrinsic semiconductors are called N-type semiconductors. P-type semiconductors. When a semiconductor material is doped with a trivalent material, 3 valence electrons of trivalent element creates covalent bonds with the silicon atoms nearby, but it couldn't provide the 4th electron and thus creates a hole, which is actually a vacancy and waits for an electron to join. Such doped semiconductors are called P-type semiconductors. Extrinsic semiconductors. Impurities such as boron, arsenic, antimony, etc. are added to the pure semiconductors by a method called doping, which increases the conductive behavior of semiconductors, and such doped semiconductors are known as extrinsic semiconductors. Now let's proceed to the p-n junction in semiconductors. If a semiconductor material is doped with both trivalent and pentavalent impurities, then both p-type and n-type regions are created in a single substance. As a result, a special barrier is created at the boundary of these two regions, which stops the flow of charge carriers and is called the p-n junction. This p-n junction formulated the basis of the first semiconductor component called diode. Different variations of p-n junction resulted in the creation of other basic components. Example, transistor, FET, MOSFET, etc. Applications of semiconductor materials. In today's world, electronics, especially embedded, will simply die if we remove semiconductor components from it. The semiconductor has its applications in almost every sector of electronics. Let's have a look at the few applications of semiconductors. Consumer goods. We can think of a world without electronic devices such as mobile phones, laptops, microwaves, refrigerators, and many more. Embedded systems. Microcontrollers or microprocessors have revolutionized the world and are considered as the base of embedded systems. Thermal conductivity. As few semiconductors have high thermal conductivity and are thus used as a cooling agent in thermoelectric applications. Light-emitting diode. Instead of heat, few semiconductors also produce light and are thus used in LEDs, OLEDs, etc. Well, that's it for the semiconductor material. Thank you for watching.